record. So welcome everybody. Thanks for joining me. This is really an informal. If at any point you suddenly can't hear me or my microphone stops, everyone, uh, just let me know in the chat. If you haven't been to one of these before, it's really informal. I'm going to try to, we probably only will get through, 7 or 8 problems at most, but I hope we can have some discussion along the way and that we can look at a few exams along the way as well. Um, a few people already asked some questions on the discussion board, which is great. So I already put those on the list. So right now I have these 5 questions that people have asked about, and when we look at them, we'll also peek at other parts of those exams. Okay, so generally this is when our final is. There's a seating chart. Do check the seating chart out. Somebody spotted like one seat was off on one of them. I hope I'll look through it again tomorrow, but it gets us roughly in the right place. We know the structure of the final. First 2 pages will be integrals. Don't forget that. Um, there will be 2 pages on differential equations, and then we have our other things. I definitely want to know my named things. Um, Riemann sums, fundamental theorem of calculus, what an integral represents, like if there were graphical questions, net change, total change, volume revolution, which I hope we'll do a little bit of each of these things. Center of mass, we didn't do this term, so center of mass will not be on your final. Comparison test was only very lightly covered this term. I know it's been asked a lot in recent finals. It actually is a helpful tool, even if you aren't required to know it. But comparison test, I won't explicitly mention or ask that. You won't need it to do a problem. If you want to use it to check some of your work, that's fine. Okay, so that's kind of the laydown of where we are. Let me just look and see. We may not do all these questions, but this also gives me a list for tomorrow. So I'm just going to take a few notes of what people have said. Number 8. Great, thank you for the list. Owen with the spring 25, number 6. Other Owen for the spring. Oh, Alex says that one was crazy. Okay, so this is crazy. Let's note that one. So we'll make sure to look at the crazy one at some point. And then we have a winter 25 question 4. That's a pretty solid list of things. Um, so let's grab one. So spring 25, I'll just start there at the top. Is spring 25 mentioned? It's mentioned a couple times. So this is mentioned and here. Oh, it has the crazy one too. Um, okay, so let's go. And then, this can continue on the discussion board. We're running out of time a little bit. My only other things I would point to is there's only so much we can do in a review session. In the end, there's lots of ways to get help, but I posted some particular topic reviews on my archive, so I'll put that in here, kind of topic specific reviews. And I will continue to add to that a little bit, but pretty much after tomorrow afternoon, I won't be adding more. Here's the final exam archive in the discussion posts. And then lastly, things I added today, like if you want advice on what to put on your note sheet, I threw a few things there. And if you get sick of studying tonight, then tell me a bad joke right here. I already gave my bad joke, which is uh, this is my definition of a tangent. It's an Englishman back from a beach vacation. So stupid. All right, let's go here. So we're going to go spring 25, question 5. So this is spring 25. An interesting thing about this is this should look familiar. So if you look at this problem and it scares you, that's bad because that was on our midterm. In fact, that's where I got that midterm question. Um, and then we have a partial fraction. Ooh, this one looks scary to me, but I know it's by parts. Um, There's that comparison test that they love in recent years. Briefly, this is actually not bad. This is less than this, which converges. So in some ways, those comparison test questions are shorter. Well, anyways. The question was about 5 and 6. Okay, sorry. I did this the other day, a couple days ago, because people were asking about graphical questions. So I made a video where I went through three of the most recent graphical questions. So you'll find that on my review page if you're having trouble with these. Yeah, let's keep going. Number 4 is total distance. So when you see total distance, you're going to first have to find the velocity. T squared minus 6t plus 8. But just in case this topic comes up, what's the first thing you do? Oh, fall was crazy. All right. What's the first thing you do in this problem? This wasn't the question. The question I was asked is the next one. I just like to peek through as we go. So step 1 is you're going to make the velocity 0. So there probably will be some reference to this idea that the absolute values make it. An integral gives us positives and negatives, or negatives and positives. If you slap absolute values around it, it makes everything positive. Yes, you find. Okay, so let's look at question 5. Question 5b, I think, is what it was, but these are related. So let's make this bigger. Make it so we can see it. Okay, so let's look at this one. See what happens. Okay. Find the area between the curve and the x-axis. So that's a quick one. And I suspect this is related to the next part. So did anybody compute this? Somebody in the chat tell me what that is. 1/6? And there's not a way to do it directly. You have to expand. So this is a simplification integral. All right, 2 people say 1/6. So we're going to go with that. This is a cut the region in half question. In the cut the region in half questions, you typically want to do this first. Anything that's so over the course of the quarter, we saw one question, I think, that looked like this, and you had to cut it in half this way, and that was not too bad. And then we had another one that looked like that, but you had to cut it the other way, and that was bad. That was the last question in 6-1. And then we have this new one that they're asking here. Okay, so that's not the shape we're dealing with. We're dealing with a parabola, y equals x minus x squared, in particular, a sad parabola. And I knew how to graph that because I plugged in 0 and saw that it was 0 and it was a sad parabola. In fact, I think the reason they wrote it this way is so that you could quickly see that if you plug in 0, you get 0, and if you plug in 1. So that's this area. So a little bit of parabola graphing. And basically I graphed when it's equal to 0. Okay, so find the constant m with 0 less than m less than 1, such that the area enclosed between the curve and the line is half of the total area. So it's a lot of words there. There's inequalities. There's a lot of stuff going on, but they mention a line. What's hard is we don't know where to draw the line. But what is m? I guess there is a little bit you have to read as we think about this. So we're going to cut the cake, but in a little different way. So m is the slope. So, one thing is we don't know exactly what it is, but I'm going to draw a line. That line needs to go through the origin, and I don't know what the slope is. So I'm going to try to draw it here. Imagine I draw it like this, and I'm trying to cut it into 2 regions. So our job in this question is to set up an integral for one of those regions and find when it's equal to half of the area. Does that make sense? Questions on that? That's the idea. So the interesting thing about this is that because we don't, I'm going to draw the picture a couple different times. Since you're thinking of an area, you're going to have to choose whether you want to use X or Y. Now, when I look at this, if I'm dealing with region 2, I really don't want to use X because if I use X, the top changes. So as I'm thinking about the problem, I could do region 1 and I could do it with X or Y. I could do region 2. So, but right now I'm just doing a little bit of analysis of I do not want to do region 2 with X. I'm removing that from my approaches to this problem. Because if I do, then the top changes. I have to split it into 2. Similarly, I do not want to do region 1 with Y because the right side changes. So to me, there's only 2 reasonable approaches to this. We're either going to do region 1 using X or region 2 using Y. So that's the takeaway here. Area questions typically are going to be about, do you know whether you want to use X or Y? And sadly, that's not going to go away. In chapter 15 of 126, you're going to need to be able to do the same sort of reasoning. So I'll talk about mowing the lawn yet again. Okay, so I think if I did this problem, I would do region 1 and I would use X. And I find a lot of people don't do that because they want to choose the one that's close to the axis. But I like region 1 because the top and bottom never change, no matter where I am. Okay, so then the rest of the problem becomes setting that up. And that may not be the best way. Maybe I should do region 2 with Y. But that's to me what the problem's about. So what's the top and what's the bottom? Let's deal with that. So top minus bottom. And the bottom is just mx. It's that line. And the top is the original function. Why wouldn't region 1 region 1 with Y would also be good. Oh, region 1 with Y not be good? Okay, I misread what you said. That was sorry. I think I said it, but I wasn't processing. So if you were to start to mow the yard this way, you got your lawnmower out and you're mowing the yard. You go forward and backwards with your lawnmower. You're always between the line and the parabola, the line and the parabola, and we're doing it based off of Y. This is what I'm thinking. Line and the parabola, line and oh, something happens right here. It changes. Now you're between parabola and parabola, parabola and parabola. You would have to split it into 2. So that's why I don't want to use Y. Does that make sense, Julie? It's this change that happens. You can use it. If you did in terms of Y, you'd have to split it further into 2 more regions. Yeah, that's the thing. So anyways, there is one challenge left to be done if I'm working with region 1 and I'm using X, and it's something I've left blank. It's where we start and where we end. So now let's think of mowing the yard again. Where do we start and end? We start at 0, we end at this unknown place. That's weird. So, to me, the challenge I'm finding is I have this unknown value. Once I figure this out and set it all up, I'm going to figure out when it's half of the total area. So we have one more job to do. I need the X value where they intersect. I need the X value where these 2 things intersect. And so I'm going to combine those. So the X value when these intersect would be when mx equals x1 minus x, which sort of bothers me, except, oh, I see why they did this now. I don't know how many students caught this. It's not, they intersect at 0, but I already know that. So you can divide both sides by x. That's why they did it in the factor form to try to give a hint. I suspect a lot of people expanded it out and then moved everything over and used the quadratic formula, which is also fine, or some other version. So x plus m is 1. X is 1 minus m. 1 minus m. If you were really stuck on the m, you could just make up a value of m and then do it once and see what happens. Okay, question on that was the idea. You finish by integrating the integral from 0 to 1 minus m of x minus x squared minus mx dx. You get 1/2 x squared minus 1/3 x cubed minus m over 2 x squared from 0 to 1 minus m. Ooh, if you aren't careful, it might become very hard to solve. But I think it simplifies. So this is 1/2 1 minus m squared minus 1/3 1 minus m cubed minus m over 2. I should have combined those, but 1 minus m squared. And I want that to be a 12th, 1/2 of a sixth. Okay, setup, are we okay? I imagine that there's another challenge here, which is, can I get the answer out of that? Did I do all that correctly? Questions on setup. How do we solve that? Did anybody solve this problem? Maybe my setup led to a messier equation to solve. Or if I simplify, maybe it's not bad. I don't know yet. But I might move on because I feel like we got what we needed to do. What would we do if the line was this? If the line was up? That actually wouldn't, it would change. So somebody's asking, what would we do if the line was a little higher? Well, then you have two parameters, so there's probably more than one answer. So that's an issue. But you would have to find both these intersection points. Tweaking out on algebra. Well, this is not a typical algebra situation, so I don't see an easy way forward unless I miss. Oh, wait, let me think for a second. So my only thoughts here are to factor out, but that's not, usually you only factor when the other side is 0. But there is something that all three of these have in common. So this is my instinct. I'm not telling you it's the right step because I don't know yet. But my instinct is I want to factor out the square. I'm just hoping that that's going to lead to a nice thing. If you pull out a square of each one of those, you're going to be left with a half in the first spot. You're going to be left, so if you take two of these out, with a 1/3 1 minus m squared and an m over 2. Do we get a 12? So then you get 1/12. Ah, for the second term, it's 1 minus. Thank you. Thank you. I was about to head down a rabbit hole. Plus 1/3 m minus 1/2 m. Does this come out? I think it does. So I don't like the algebra here. It's very unique to this problem, but let me keep going. So I'm getting 1/2 minus 1/3. So 3/6 and 2/6, that's 1/6. And then I'm getting plus negative 1/6 m. So this maybe the way I approached the problem led to this, but I think something happens that's just darn lucky here. So I'm going to factor out the 1/6, and I'll take this in steps. Do you see a reason we can solve that? It's very special to this problem. I don't like this. This is gonna frustrate people. Algebra and the differential equation problems is harder sometimes in the solving. My only consolation would be in a problem where this happens, it affects the end. Does that feel good? No, but if you make a mistake in the solving, it's not like you lose a huge chunk of credit. But this is very particular to this one. You know, I think that if we expanded, we would get some cancellation, so we'd get there too. But this can be done because you can take the cube root. We don't have a nice general cubic formula. So that's why when I saw this, I was like, oh no. So if you felt the same, then I agree with you. The cubic formula called the Cardano's formula is this huge messy thing. So we don't usually ask you to solve that. That's why my instincts told me to factor was like, this must clean up or we can't do it. So anyways, it's 1 minus 1/2 to the 1/3. Maybe if I would have set it up a different way, that would have been more obvious. But I would not lose sleep over the algebra on that one. That was probably a hard finishing part, but the vast majority on the credit on this problem would be setting this up. I guess the algebra is like the separator there. Okay, let's move forward. But that became my mission was to clean up. I didn't know where it was going to go. It worried me. Normally I like algebra. Okay, so somebody also asked about question 6. So we did this one, set up, but the algebra was terrible. And then question 6, Alex said wasn't the crazy one. It was a different one. But since I have the exam open and we're right here, I no, I did this in maybe in office hours with somebody. I don't think I've done this in class. Let R be the region between these two things. Set up an integral equal to the volume of the solid obtained by rotating the region around x equals -1. So it's a volume question. Oh, do I know what the test writers had in mind there? I don't. Sometimes some people are like, I like to have a question that's pushes them on their algebra or something in one place on the test. I don't know. Um, so if in order for me to do this problem, I do need to graph. And so I think the person who was asking me about this in office hours, the question was, what does this look like? But in general, I would say things like this are kind of nice to know what the graph of this looks like, and the graph of this looks like, and the graph of this looks like. And sometimes we miss out on the fact that one of the easiest things to think about is what happens as you go to infinity. So we tend to plot 0 because it's easy to plot. Right? If I plug in a 0 to here, I get a 10. And it's a sad parabola. But the other thing that's sometimes easy to plot is what happens way to the right. So on this problem, I know as you go way to the right, it gets close to 0. So that helps me graph. So I have something that has an asymptote over here, and that right away hints at the fact that I might know what this looks like. The reason I drew it like that is because if it doesn't hit it, then the question doesn't even make sense. So I think we're dealing with something sort of like that. Okay, that's to me an important piece of the story. Even if you didn't know the picture, you would need to recognize that this is the top and this is the bottom. You could even plug in some values here if you were stuck. Don't plug in 0, but plug in 1, plug in 2, plug in 3. So I think that's what happened on this question. Oh, it's like 2 in a row too, because we just did a big algebra problem. Students might have gotten stuck here. Oh, it was 2 in a row. I don't know. These exam writers liked algebra. Um, but honestly, I probably wouldn't be solving that because I would have plugged in 1 and 2 and 3. And when you plug in 1, you actually see that's where it is. I would have done that as part of my graphing anyways. When I plug in 2, I get 9/4. When I plug in 3, oh, those are the answers. So in the process of graphing, I happened upon my answers. Ooh, so it's 2 in a row. I see what's going on. That's why everyone's tweaking about algebra or whatever somebody said. Because they probably thought, now how do I solve this? I don't think our exam has is, but this is solvable as well, but it's a fourth power. But it's not really a fourth power. It's actually a quadratic in disguise. But I would say if you got stuck solving there, I would plug in the whole numbers to give yourself a feeling. Anyways, let's leave that part and just talk about the setup. So the line is, and on a final, definitely do that. If you're stuck, make a little table, 1, 2, 3, even more values, plug in values. Okay, so I'm trying to give you a few ways. Do remember you have more time on the final. Okay, so we're revolving this around this axis. You can actually do it either way. So give me one. Do you want to use X or Y? X. Y. Well done. Um, one for each. Well, X is winning. The vote currently is 2-1. Uh, it's alternating. It is a true alternating. It doesn't take long to set them up. So you've convinced me. We're going to do both. So here we go. This is the graph again. This is the parabola. And I'm going to label it. So let's label it with X here. And then separately, I'm going to label it with Y. And so maybe I'll quickly ask several questions in the chat here, and I'm going to zoom way in so we can do this. I would like to know first what this is. So that we can label. What is that? Length. That's going to be important length in the problem. And then we're going to also get this other, yep, 9 over x squared. And then we're going to get this other length here. And this is y equals 10 minus x squared. And this is y equals 9 over x. So that's the bottom and the top. So now we know what we have. And then let's figure out what we want. We want the volume of the resulting, whoa, I didn't know we did that. The resulting shell. I should have labeled one other thing. I typically label, when I put an X here, for emphasis, I say, remember, this is what X means. Okay, so we have two things to figure out. One is what the radius, the pattern for the radius is, and the other is what's the height. So we say the integral from 1 to 3 dx 2 pi blank blank. And so we need the radius and we need the height. And in general, these problems, the only thing that changes if you make that axis over a little more is you change the radius. Height doesn't change. It's just how far it is between these two. So 10 minus x squared minus 9 over x squared. But what's the radius? Tell me that in the chat. X plus 1, lovely. So there's option 1, or one of the options, the x option. The y option involves labeling these two things. So because we're rotating around the line x equals minus 1, the radius is 1 larger. Let me, and all that does is increase the radius. It doesn't increase the height. Not this, we don't want that. Let me see here. Do I have a quick visual at the ready about this one from class? Did I make it so I could change that? No, I didn't. Never mind. Not worth it. So it would work if you use washers, but you'd have to be using Y. If you use X and you're using a vertical axis, then you're using shells. The reason the radius is X plus 1 is because that's X and that's 1. Sometimes people are worried about the fact that there's a negative there. If that bothers you, then you could do right minus left, X minus -1. But that's just another way to say X plus 1. That's what that is. If you're using washers, if you choose to use y goes from 1 to 9 dy. You do pi times the outer radius squared, pi times inner radius squared. And you would have to figure out what the inner radius is, how far it is from here to there, and what the outer radius is. Oh, that requires you solve for x in terms of y, which I don't really want to do. So I think I'm going to not do that, but you could solve for x. You could solve this for x. If you're worried about how the radius affects things, if you change this problem and it's just the y-axis, then this is what it would be. The moment you shift it over 1, it just adds 1 to both of these radii. Those are the 3 places that are affected by having a different axis of rotation. So I think I might leave that and just say something here about volumes because a lot of it involves carefully labeling. Oh, here we go. Here's what I meant to show you. So if you just want to practice volumes, I do a whole bunch of questions here. So you could take one, pause the video, do it, see the solution. Very worth your time because the ability to label graphs is pretty valuable. Okay, I'm going to leave that and check back in with where we are in our problem list because I feel like we've done. So we did a volume and we did an area. So let's look somewhere else. Let's look winner 25 just to pick something else. And question 4, question 6. So I'm on winner 25. Let's make it big. Partial fractions. Something else that looks like partial fractions but must not be. Substitution. Oh, I don't like this question. I wouldn't ask that one. Um, let's see, let's keep going. It could be that the instructor that quarter was the only instructor and they warned students, so I shouldn't, it depends on the quarter. The question is 4. 4 was one of them, and the other one was 6. 6 is a volume. Did somebody ask about 4? Give me a thumbs up if you did. Okay, somebody did ask about this. So it's some sort of acceleration velocity question, but there's subscripts. There's something unusual going on. A drone starts from a height of 2 meters above the ground and flies straight up with a velocity of this. At 10 seconds, its battery fails. So from that time on, it falls. Okay, so this is a 2 problems in 1 problem. What is the drone's height above the ground at the moment when its battery fails? Okay, so when I read this question, I feel like there's just 2 different problems. There's when it's going up. It's just me trying to make sense of it. And then there's the part when it's going down. And so we just need to separate those things. So when it's going up, it tells me the velocity is 0.3 t squared. And when it's going down, it's just falling. So don't let the subscripts scare you. The subscripts were meant to sort of emphasize the fact that, hey, there's two problems in one here. So the first part, part A says, what is the height at the moment its battery fails? When does its battery fail? 10 seconds. What is the height at 10 seconds? So the question is, what is the height at t equals 10? So a lot of these questions that look unusual, if we read carefully, it's telling us. So up to 10, we're only using this formula. So we don't need to do a lot here. The velocity is this. We need to integrate. So the height is 0.3 over 3 t cubed plus c. We need to figure out what c is. What is c? Does anybody spot it? There is some initial information about the drum. It's 2, yes. They told us that the initial height was 2. So c is 2. So then the question says, what is the height when you plug in 10? So it's going to be 0.110 cubed plus 2. So it's 0.1 times 1,000 plus 2. Yes, 0.1. So it's 100 plus 2. It's 102. Does that match up? Does anybody else get that? Yay. Okay. So that, on a careful read there, you see that the first part was really about finding C. Okay, so the second part says now, I mean, it's trying to give you a somewhat more realistic problem. This is how it might be. So then it fails. How long does it take the drone to crash to the ground from the time its battery fails? So my advice in this problem is just to treat this as a new problem. You kind of like to have time zero be whenever something starts. So let's call this time zero and not 10. That's my preference. You could do it 10, but I'm going to say at time zero, the height is 102. I'm going to pretend I have a brand new problem where the acceleration is negative 9.8. And then we're going to do a tomato problem. This has become a tomato drone problem. The velocity is negative 9.8 t plus a constant. The height is negative 4.9 t squared plus t plus a constant. I know that when I plug in 0 here, what I'm now calling 0, the height is 102. So I actually know d is 102. But there's something missing. There's no c. And I suspect people doing this question used c equals 2, but that's wrong. So this is the challenge here. This is more about kind of reading and thinking through what our model represents. So it's a more conceptual problem. What is C for the drone after it starts falling? Because I know that the height, the initial height is 102. Oh, 30. So you had to do more work. I was going to try to get it wrong. So it was on its way up. We don't know. We'd have to go back. So this is the one part where you have to go back and look at the previous problem. Because all we know is that the drone was going up and then its battery went dead. And so we need to figure out what its velocity was at that moment when the battery went dead. So that's the unknown in this. What was the velocity at the moment when the battery went dead? Okay, so we can plug that into the previous part. That was the tricky maneuver. 10 squared. So it's 100 times 0.3. That's where you got your 30. 30 meters per second upward. So this is like throwing a ball up in the air. It's at this height. we're ready to go. So this is negative 4.9 t squared plus 30t plus 102. And then what does it want? How long does it take for it to crash to the ground from the time the battery fails? So how do you finish the question? Yep, you want to know when this is 0. So that's it, negative b plus or minus square root b squared minus 4ac all over 2a. There's going to be two solutions, but you're going to want the positive one. That's why it said round to the 10th of a second to suggest that maybe it is not a nice value. So there you go. That was really was a tomato problem. If you do get a multi-step problem, I would just do what I did there, split up your thinking. That's really the challenge of it. Is that okay? Can we leave that one? Did we sort of answer that question? Yeah, okay. There was something else that was asked here. What was the other one asked about? Winner 25, number 4, and number 6. We looked at 4. Here's 5, find that area. Here's 6, do a volume. Set up, but do not a volume. Maybe we can do this quick. I think this is a fairly quick volume. They give you this curve, which is this. They give you x equals 2, x equals 0, y equals 0. And they say they want you to revolve around the line x equals 3. Here you have to use x. Actually, does this? Yeah. You really want to use x because the left side changes. I want to mow the yard this way. But if I use x, then this is what I draw. And I revolve it around, and that gives rise to a shell. So my immediate, well, it just says setup, right? So the integral from 0 to 2 of 2 pi radius height dx. So tell me in the chat what you're going to put for the radius. I think you all have it, but I'm just labeling. This is essentially what we're doing when we're trying to find the radius. The radius is always how far from the axis of rotation to where you are on the curve. So yes, this is going to be 3 minus x. And then the height is the function itself, so that's e to the square root of x. Somebody's asking a private question in the chat, but are we okay with the setup there? You really want to use shells, so I'm happy they asked us for shells. It'd be much harder if you weren't. And then the next one says an integral to the volume of the solid obtained by rotating about the line x equals -1. Oh, boo, we do have to use washers. Uh, it's not terrible, but I'd much rather use shells. I'd much rather use x. Do we want to see part B or move forward? Okay, let's take a look at part B. There's a mixture. The person who's asking a private question about the tomato problems. This is a general fact that if h represents the height of a moving object, the derivative of the height is the velocity. And the derivative of the velocity is the acceleration. So if you're going this way, it's derivative, derivative. If you're going the other way, it's integral. So in tomato problems, we know the acceleration is negative, whatever, 9.8 or 32. We integrate to get velocity. We integrate again to get height. Does that make sense, Julie? Great. Okay, so let's look at this one real quick. There's a mixture of opinions on what we should do here, but so now I need to redraw it. Let's look at this. I did a bad job drawing it, but that's good enough for our purposes. We're rotating around the line x equals -1, and we're being asked to use washers. So that forces us. And that forces a method. So washers is the perpendicular cross-sectional method, which means we are using y. The reason it bothered me that I'm using y is because there's two different patterns depending on whether we're above or below this. So we have basically two regions to deal with, region 1 and region 2. On region 2, this is on the left. On region 1, this is on the left. So the bad news is we have to split them up. So we'd have to go from y equals 0 to wherever this is, which I don't think they told us yet, but I can get it from the function. It's 1. And when okay, so here's our first challenge. If we're using y, we need to know what this y value is and what that y value is. So take a second and see if you know what those y values are. So y equals 0 is the first one. The function is y equals e to the square root of x. If I plug in a 0, I get e to the 0, which is 1. So that's 1. The top one's a mess because it's what you get when you plug in 2. So it's e to the square root of 2. So the answer is going to be the integral from 0 to 1 dy. And then separately, we're going to have to do the integral from 1 to e to the square root of 2 dy. We'll have to add those together. So it's sort of a beast. So I need more space. Dy, and then plus the integral from 1 to e to the square root of 2 dy. And there's going to be a pi. Let's just pull the pi out. Pi, outer radius squared, inner radius squared. Outer radius squared, inner radius squared. And the rest of the problem is filling in those patterns. One of the radiuses never changed. The outer radius is out here at x equals 2. So if you were to stand in the middle and start to go for a walk, and you get to the very edge, that's going to be 2. And that's true everywhere. So think about where 2 goes. It's not 2. This is 2. So it's actually what? So the same thing goes in both these spots. What is it? It's 3. Yeah. All right. 1 plus 2 to emphasize it. 2 because this is 2, 1 because this is 1. You might say, well, it's -1. So you can do 2 minus -1 if you prefer, or I just like to write 2 plus 1. That's the outer radius. The inner radius changes. Initially, it's just 1, and then it's this 1 plus something. So the hardest algebra part of this problem is right here. We have to somehow label this length, given the fact that y equals e to the square root of x. So here's your algebra challenge for this problem is, can you get x by itself? So take the log of both sides and square. So this is going to be log of y squared. So I hope if you step back in this problem, you can see that, okay, this was telling me I needed to use y. I knew sort of the setup. The challenge was filling in these pieces. And the reason we needed 2 was because this changed. The inside bound changed. Okay, can I leave that one? How are we doing? Somebody's privately asking me about the never end. That sometimes appears on final, so I'm not going to rule that out completely. Unfortunately, you can't write it as 2 log of y. Good question. Um, log of y squared is 2 log of y, but that's not the same as the log of y squared, sadly. There's a pi, but I snuck it in out here. Good point. So this is not what we want. We want this. So it's not a good way to simplify that. So there's a couple problems from winter 2025. So I might leave that and hit something else. I think we'll go till 8:30. So we've done a lot of volume, I would say. That was a volume, but this was a volume. I forgot what this was. Winter, that was just a few minutes ago. Oh, that was a tomato. We'll call it tomato acceleration. Um, can we do an application of differential equations? That would be lovely. If you're looking for volume practice, I would say use my little video on it. But let's see. So winner 24, number 10 must be um, a differential equation problem. Winner 24. Okay, partial fractions. And that's the integration by parts somebody was asking about. There's a trig substitution. There's a substitution. There's a total distance, arc length, pumping, graphical, volume, centroid, which is center of mass, and we're not doing that. Differential equation with an initial condition, and then some oh, that's an interesting application. So it probably looks worse than it is. So let's take a look here. Oops, I mean to go bigger, not smaller. Okay, there is some function, and all you know about it is this, that the tangent line at a given point is the square root of the y value. Oh, somebody's sharing something. Thank you for doing that. Um, so this is actually telling you something about this function. So if this were the x value and this were the y value, that height is the function. So when we write y equals f of x, this is that height. So when they're talking about the tangent line, wait, on the curve intersects the y-axis at this point. Oh, that is a little different. Different than I was my first read. The tangent line to the curve hits here, 0 square root of b. So my thinking is, what does this have to do with differential equations? But there's a mention of the tangent line. So the slope, this is the slope of the tangent line. And there's a reason we know that slope. So think about why we know the slope of this thing. And so even so that this was an unusual problem for this, but we actually know the slope is this. So what they're saying is that for every point, the slope is the y value minus the square root of the y value over x. It's a little different sort of question. So it's whatever the y value is minus the square root of y value over the x value. So they gave you the description of a differential equation. I don't know that this is on very many old tests, but they gave it to you as a verbal description. They basically said the slope of the derivative, the tangent line, and I don't know why I used a t because we're using x. The slope of the tangent line equals the slope between these 2 points. So this is really meant to be the following: separate, integrate, and hope that we can go from there. How is that review sheet? Oh, it's kind of written in my old style. I haven't had time to rewrite some of these old review sheets, but there's plenty of them. All right, let me get rid of that. So that was a little different. I feel bad spending too much time here because I know that people want to talk about differential equations. This is a differential equation, it's separable, but there wasn't really the setup in the same way that we have like in a mixing problem or in other applications. The hard part here was translating the fact that they were saying the slope of the tangent line equals this. Then we'd have to integrate both sides. So I feel like I'd want to switch to another. We can talk about integrating. How would you integrate this thing here on this side? What would you have to do? It's a u sub. You do u equals this. But I think we would get more out of this time if I'm going to do the following. I'm going to make an executive decision here that a few people have mentioned differential equations. So let's do a differential equation hunt here. All right, I'm just going to pick somewhere. I'm going to go to the end. This is what I would do if I was a student, part of what I would do. So this is a differential equation. It's a mixing problem. So in my head, I'd be thinking, I'm going to need to read this carefully and figure out what these pieces are. So let's just talk about that for a second to kind of put people at ease. So a large vat contains 10 liters of salt water. Let's just talk setup for a moment. There's it coming in at 2 liters per hour. It contains 3 grams per liter of salt. It's thoroughly mixed and it comes out at 2 liters per hour. Okay, Can you fill in all these pieces? Go ahead and you can even just write out the whole thing. And then we're going to immediately go find another one. So what goes in all the spots here? So it's 3 times 2. So 6 minus what? Go ahead and type all of this in the chat. So I just want to quickly set one up and then immediately look at another differential equation application. The key in these mixing problems was what goes here. Yep, so it's hard to type in, I know. I asked y over 10 times 2. So altogether, this is going to be 6 minus y over 5. And then when you go to separate, it's going to be 1 over 6 minus y over 5 dy is equal to 1 dt. And then you'll integrate and be on your way. Questions on that one? I want to immediately grab another one. So we're going to click on another one just to I want us to see several of these application problems. So the challenge will be to integrate, simplify, put in the constants. Okay, let's do another one. Cool, are you on with my program? We're going to quickly look at a few. Yeah, so let's do no particular order. Fall 2022, just keep going up. I'm going to flip to the end. Okay, this one they gave the differential equation, so you don't have to think about mixing or anything. So this is a straight solving. I think we did not particularly talk about carrying capacity, so I probably would not ask that question. So rather than get bogged down there, this is just straight about solving, is really what this question's about. So even though that looks a little different, it's just to separate. So you need to get all the p's to the other side. And the only way to do that is to divide by all of them. It's not pretty. So I know the moment I flip the page that, okay, they gave me the differential equation. My comment, just because you've done quite a few of these now, when you have something like this with a fraction and a fraction, I always clear the denominator, meaning I'd multiply top and bottom by 1,000. That saves you some of that messy algebra that people are getting worried about. And I never like to move forward with a fraction and a fraction because I can always simplify in this way. But really, what is this question about? It's about partial fractions. So the real part of this problem where you do some work is the following. So this is the reason this one's tougher is not because of setup, but because there's more integration that's involved. So that's another type of differential equation problem. Not so much the setup, just this thing here. All right, let's look at another one. So you'd integrate, simplify, plug in all your information. Technically, I think that's called the logistics model, but you don't have to know that name. Let's do another one. So fall 22, we're just going to see what it is. Last question on fall 22. Mixing problem. This time it's milk. A large vat, 2,000 liters of milk with 2% fat by volume. This one's a little different because it gives them as percentages rather than kilograms per liter. But that's another way to say the same thing. With 4% fat is pumped in. So we're doing 2% milk and 4% milk. The milk in the vat is kept thoroughly mixed and is pumped out at a rate of 20 liters per minute. It's a lot of information to read through, but after you've done a couple of these, the numbers start to jump out at you. 20 liters per minute, 20 liters per minute. And I find problems like this are just so much easier if you sort of already have a game plan. So I already have the flow in and out, and I already know that this is going to be Y over 2000, where Y is the amount of milk. So the only thing is what percentage of this that's coming in. A large vat contains 2%. Milk with 4% is being pumped in. So 4% of this. So it says it as a percentage, but that means times 0.4. So to me, the difference there, and I'd probably want to do a couple, is making sense of thinking in terms of percentages, but there's another mixing problem. Let's just glance at a couple more. If the inflow and outflow are different, then the volume changes. That's what is affected. Let's see if I can find one of those. Here we have a bacteria problem. This one's actually pretty straightforward. I've had a few people ask me about this, but this is actually a model we've already solved. So you could even quote our fact that y is equal to c e to the alpha t. This one we haven't solved, and so you would have to solve it. Multiply both sides by dt. Divide. I think sometimes just the fact that it's an alpha instead of a k or something throws people off. So this is one where, so now we've seen a mixing problem where we had to set it up, a problem where the differential equation was given. We saw another mixing problem where we had to set it up, and here's another one where it's given. So I'm trying to see if I can find the volume changing one. Pumping problem, I mean mixing problem, I shouldn't say pumping. That's the that's the one we did 2 exams ago. That's the weird one we started with. Mixing problem, mixing problem. Newton's law of cooling. Newton's law of cooling is sometimes the most straightforward because we've already completely solved it. And so the problems become more about just plugging in your information to the right places. The room temperature, a plate of pasta has an internal temperature of this when it is placed in the oven whose temperature is this, 40. And we actually already know the full solution to this. But we'd have to put in our initial conditions. So I guess I haven't seen a changing volume. I know someone asked me one recently. Oh, did I pass it up? Oh, I passed it, but we'd already, I have already done this one. When did I do this? I don't remember. Maybe in office hours. So this one said that you started with 100 liters. Okay, in one of the classes. Oh yeah, I did that in lecture. You started with 100 liters and it was going out faster than going in. So the biggest change is that there's a variable here. Let's check in. So that was a pretty big chunk of differential equations. I know we didn't solve, but let's go somewhere else. So are any of these people still on and or still awake? Yes. Winner 23. Okay, Lucas, thank you. Winner 23, number 3. Tomato problem. Yeah, we can hammer this out. Let's go. So to me, these problems are about, I mean, not to me, these problems are about um, initial conditions. My preference is to not really change my approach. I just do them all the same way. Sometimes there are additional unknowns in a problem, and that's usually what throws people off. But I'm going to assume we start right here. Some object, this is time zero. I'm also going to assume this is height zero. Those things are, you could change those things, but I tend to like to do it all the same. So the moment I see the acceleration is constant that tells me what the second derivative is. And in this labeling, down is negative. That means the velocity is negative 32t plus a constant, and the height is negative 16t squared plus ct plus d. So the rest of the problem is about what numbers do we put in. So now let's read carefully. If you've done a few of these problems, you know that this word is pretty important. If you miss it, it really throws things off. A tomato is dropped. Yeah, so I would use v of 0 as 0. Now it says you don't know when it's dropped, but I'm just calling that time 0. So v of 0 is 0. That means when I plug in a 0 here, 0 pops out, and so c has to be 0. So that makes my problem a little bit easier. See, this is 0, this is 0. Okay? Assuming I've labeled like I've done. So I've used v of 0 equals 0, and I concluded that c was 0. 2 seconds after it passes your window, it hits the ground. Oh, this is a homework question. So let's put our window right here. And we're standing inside here. And it passes our window. It's a tomato, so it's gotta be red. It passes our window. And then 2 seconds later, it hits the ground. Splats everywhere. Okay, so when I look at this problem, I go, well, did they tell me what this time was? No. Did they tell me what this time was? No. They told me that something takes 2 seconds. So it takes 2 seconds from here to here. 2 seconds later. And to me, this problem illustrates one of the, I would argue, the most important technique in problem solving. The reason this problem is confusing is because we don't know what this is. And once we say that, the method becomes really clear. Label it. Label your unknowns. It's really powerful. So I just need some letter and I need to label this. So I'm going to use, I often use A. I feel a little weird because I'm using A for acceleration. You could even label this B, but we can do better than that. So we have, if you're ever unsure what to do in a problem, label all the unknowns. But we can do better. Instead of saying B, what can we say? How can we say 2 seconds later? So I don't really need three unknowns. We can say A plus 2. To me, that's it. The moment I label this as an unknown, the problem lays out nicely. Some people try to solve it different ways. They try to make that time 0. They try to set up an integral. I think even the solutions for this final do it in some weird way. But I believe strongly in if there's something you don't know, label it. And I feel like the moment I do that, I know what to do in these sorts of problems. So I do know what the height is at time A. It's 320. So the height at A is 320, which means negative 16a squared plus d is 320. And I know the height at A plus 2 is 0 because it hits the ground. So I really like methods like this where I can just see everything. That's the problem. And the challenging thing was that this other time was unknown. If it's thrown in some way, it makes it so that this isn't zero. That's the only thing that changes. They'd have to tell you that. In this problem, they gave me three facts because there were three unknowns. One unknown was C, one unknown was D, and the other unknown was when it went past my window. That's what the added unknown was what was confusing about this problem. You're always typically searching for two facts. Okay, so if you're going to finish it, I mean, when I do a problem like this, the moment I write that down, in fact, the moment I label it, I feel like I'm done. But the challenge is this algebra. That algebra is actually not that bad. We need to combine these two. Take one equation, solve for one variable, shove it in the other. You can also add side by side, subtract side by side, but the take it and shove it method is the method that always works. So if you're trying to get it down to one variable, I shoved this in here. I got 320 plus 16a squared equals 0. So that becomes my mission. Take my two unknowns, turn it into one, and then hope I can solve that. But I think this turns out actually really nice. A squared plus 4a plus 2 plus 320 plus 16a squared is 0. And so I get, why I'm squishing it in here, I get negative 16a squared plus, not plus, minus 4 times 16, so 64a minus 32 plus 320 plus 16a squared equals 0. And we have it. Yay. So we get negative 32 plus 320 is 64a. What is that? 288? So a is 288 over 64. I definitely could have made a mistake, but I really do think that this highlights a common theme, which is problems that sometimes the reason they look hard is because there's an additional unknown, and the moment we label it, it like frees our mind to think through it. Good. Does that answer whoever's question this was? And definitely check my work. I don't know. Isn't it supposed to be plus 4? There's a plus 4 question. It is supposed to be plus 4. Thank you for catching this. This should be a 4. This should be a 64. Oh, that makes the numbers not maybe slightly nicer. No. Negative 64. So this is not 288. 288 was just a bad approximation. 20 and 40. So 260, 256. Oh, that's better. Yeah. It ends up being a nice number. Thank you for catching that. Winner 25, question 2B, substitution. Let's close that. Sorry, I'm just looking at something in particular. I'm not going to ask this because I've talked about how you can quote secant cubed. Because I say that, I feel like it's not, my students won't understand that question. So I would argue against that on my final. We meet together and talk about the final. So each instructor has a little bit of veto power. But we all have to compromise a little bit too. I think that's what you're asking about. It actually says integration by parts. Integration by parts is not how I would do that problem. So that's the other thing I don't like about it. I have a different way of doing that. I think I posted a video about how to integrate secant cube. So if you want to see, I do it several different ways. But I just allow students to quote it because it's a big problem no matter how you do it. And it's not a standard technique. Yeah, Luke, the only time I use that method is when I'm doing e to the x cosine x or e to the x sine x. These other problems that people do that way, I know it's a correct way, but I've tried to organize the methods into ways that are more, general instead of having to be clever. So that's why I do it a different way. We just looked at, did I look at winter 23, question 3? That's what we were doing, yes? So that was tomato. Spring 22, question 6. Is that person still here? Owen second's a different one. Above the secant cubed. Autumn 25. So nobody has jumped up for spring 22, question 6. Yeah, typically, somebody's asking. Typically, if it's an extremely complicated differential equation that doesn't match something we have talked about or seen in the worksheet, then we would give the differential equation. That's true. Is the winter 25? Oh, that was one we just looked at. Are either of these people still here? Winter 23 or spring or winter? Yes. Spring 23? Spring 23 3. I'm trying to keep with who asked questions first. Thank you. Okay. So this is some sort of train. A train is traveling back and forth along a railway track, starting 4 miles south of King Street, heading north. It's like an Amtrak or the light rail or something. We measure its velocity at T hours to be this. Where is the train in relation to King Street Station after 45 minutes? How many miles did the train travel in 1 hour? This is a total distance question. What did I just do? I don't know. Okay, so oh, I clicked the wrong button. This is total distance. So I know in this problem I'm going to be doing, so 1 hour, 0 to 1, the absolute value of 60. I kind of jumped ahead, but I was looking at this question thinking, what are they talking about with velocity? It's probably some sort of total distance. So this is really what the question's about. Oh, you're asking something else. This question is asking about how far is it in relation to where you started in the first 45 minutes. Actually, I've got my screen in the way. You start 4 miles south of King Street Station. So this question is really about, and I'm putting 0.75 because everything's in hours. This is 3/4 of an hour. Um, but the real idea of this problem is this represents what we called displacement. And this represents total distance. Displacement, the integral itself, when you integrate velocity, it tells you how far you are from where you started. So if we have the station here, and we start 4 miles this way, and then we compute this integral and we get something. It's going to tell you what your displacement is, how far you are from where you started. So it will tell me how far I am this way or this way, whether it's positive or negative. But it won't tell me if the train has turned. I mean, if the train goes this way for a while and then comes back this way, it'll just tell me the displacement. So this question is just asking you to integrate. That's an integral we actually know. It's negative 60 over 2 pi cosine of 2 pi t, evaluated from 0 to 0.75. So it's negative 30 over pi, and then whatever cosine of 2 pi times 3 of force minus cosine of 0. Every disk has a washer, yes. Washer and disk problems, just treat them all like washer problems, but a disk has inner radius 0. What would be the first step in part B of this question? You have to find when this is 0 in order to know where it turned. So you would have, in order to solve this question, you'd have to remember when sine is 0. And that happens a bunch of times. If you don't remember this story, this was the Dr. Lovelace Goes for a Run story, where I run for a while, I turn around, I pass out, the ambulance comes, and they say he only got 3 feet from his house. But I really ran several feet this way for a while, and then I ran back for a while. But the only way you can know how far I ran is to know where I turned, which is what this is. So this is a similar story. How do we know its absolute value for sure? Um, this how many miles? Kind of the problem as a whole tells me that why are they even asking this? They're asking how far I am from where I started. It has a sine and cosine. The train goes up and down. So a lot of things kind of were hinting to me, but this how many miles makes me think distance. And if you're trying to find the actual distance, then you need absolute values. Let's look at something else because I want to make sure we hit a few things. That was spring 23, number 3, I think. What is this winter 23, number 8? That one's easy. Skip. Centroid is another word for center of mass. I'm not explicitly going to ask you about carrying capacity. Now, sometimes that's helpful for like interpreting your answer, but no. Okay, there were other things. I think we hit a lot of these questions now. So now I'm going to go back. Somebody's asking about fall 25, number 6. 2 people are. So let's look at fall 25. Number 4, I did online. Number 5, I did in my video. Number 6. A lot of people are asking about this, but I think the question is just whether this is plus or minus. I'll accept either. Technically, in this class, we've only been doing the magnitude. But anyways, it's a lot to read through this problem, but it's saying you have 2 objects, like a magnet and another one or something, and they're being pulled apart. As you pull them apart, the force becomes less. So this becomes lighter in some sense. This is a leaky bucket problem. Just like a bucket going up, getting lighter, except it's going this way or whatever. So they say the force as you move it away, when you get R away, so I'm just reading this, electrical force acting on a charge is given by this. So they're telling you the force. That's what's sort of the key. And then they give you a bunch of constants. This problem is playing the game of what if you're studying something in the future and they tell you this force and for whatever reason you need the work. We know that work is the integral of the force times the distance, in particular if it's a leaky bucket problem, something where something's just getting heavier or lighter. It's going to be like this, dx or dy, whatever it is, dr. So in reading all of this, you had to say, oh, it's just asking me to integrate that. That's what this question is asking. And everything on top is a constant. So that's really what this question was about, was can we read through all the smoke screen there and realize it was asking what this was. Now, the question everyone's been asking me about is about whether the plus or minus needs to be there. Yeah, I'll be posting a recording of this. Did I hit record? I did. Yes. Okay. Made me doubt myself for a second. Okay. Yeah, I'll be put. It takes a few hours to process, so probably not till tomorrow morning. So I don't. I mean, I don't like this part of the problem because I don't expect us to think about, these values here. So I'm perfectly happy with somebody saying negative, whatever the answer is in the archive. Um, okay. Somebody is asking about winner 18, question 5. Oh, no. Oh, do I have winner 18? Good. So there we go. By parts, trig sub, partial fractions, weird question, improper. Okay, we have a couple improper. You're asking about question 5 now. Question 4 is, that's that homework question. Oh, it's a visual problem. So let's take a look at this. Gonna move this out of the way. An acceleration of a particle moves on a straight line during the first. Wait. The acceleration of a particle that moves on a straight line during this time is given by this. So this is another one of these that it's like two problems. If we wanted to be fancy, we could even write what the acceleration is. This is just going to add confusion. Why am I doing this? Yeah, this is not helpful. Ignore what I just wrote. There's the formula for it, but it's a line, y equals x, and then it's a horizontal line, y equals 1. Find the velocity in the position at 3. So this is about how do we put things together. I guess the thing to take away here is what would you do being thrown into this situation? What would we do? And the problem is this is like one of these problems where the acceleration is one thing for a while and then it's something else. So whenever this happens, just split up your work. So let's first figure out what happens in the first few seconds. First second. So in the first second, the acceleration is just this line, y equals x. Find the velocity if it starts at rest and its position is 1. Okay, so the velocity will look like, these are the things I would do if I was stuck. I would say, I don't know what's going on. The position or the height is 1/6t cubed plus ct plus d. And that would be the answer if it wasn't for the fact that things change at 1. Do we know anything? So if I just, like I said, if this just continued and we couldn't see this, that's what it would look like. The velocity would represent the area. And we know a few things. Does it say if the particle starts at rest, started at rest at position 1? So instead of saying height, I'm going to say position. So they're telling me that V of 0 is 0 and it starts at 1. So we can figure out what these things are. So I guess the one tricky thing I did is I realized that that was this line y equals x or y equals t. Okay, so I know this is 0 and I know this is 1. So I've made progress. This is t. I've stalled for time here. This is the position. But there's a problem. And the problem is that stops working when you get to 1. So after 1 second, the formulas are going to change. They're actually going to become nicer. So starting at 1 second, you're going to have the acceleration is 1. So the velocity is going to be something. You do have a choice to make here. We could think of this as a new problem starting here, like this is a new t equals 0, or we could just leave it as 1. Let's just leave it as 1. Let's see what happens. So if we integrate, we get t plus a constant. If we integrate again, we get 1/2 t squared plus ct plus d. So I would say if I was stuck on this problem, these are the things I would do before I let myself be confused. Thanks, Alex. Thanks for being here. So now is the challenge. Like, what is going on at the in-between time? So let's go a little further. And I think that whoever wrote this question was thinking that if someone gets confused by the multi-step, hopefully they still do a lot of these other things. But it's going to take some careful thought to sort out what's happening. So I actually know something about the velocity at 1 and the position at 1. And there's a reason I can figure that out. So to me, this is the hard thing to see is why do I know the velocity at 1? Yeah, thanks for being here, Anna. Because at 1, it's basically I need to know this transition point. So when I plug in a 1 here, the velocity is a half. And so it's going to continue. So this has to be a half to match up. And when I plug in a 1 here, I get the position is 1/6 plus 1, so it's 7/6. That then are the numbers that give me initial conditions here. So when this is 1, that's a half. So 1 plus c is half. C is negative half. And when I plug in a 1 for the position, 1/2 plus c plus d is 7/6. Oh, so d is 7/6. So then I get the velocity is t minus a half, and the position is minus a half t plus 7/6. Good question. The 7/6 was the location at time 1. So the tricky thing here is in order to figure out where to start, you have to know where this one leaves off. So the velocity at 1 is 1/2 1 squared, or 1/2. And the position at 1 is 1/6 1 cubed plus 1. But that's 1/6 plus 1, which is 1/6 plus 6/6, which is where I got the 7/6. Yes, you can write your notepad and then print it off, but it does need to be 8.5 by 11 double-sided with a note sheet. Okay, so at this point we have it. We have the formulas. And then what was the question? Find the velocity and position at time 3. Okay, so at time 3, the velocity will be 3 minus a half, which is 2.5. I wanted to get there because there's one comment to make. 2.5 right there is the area of this. You can find the velocity without doing any of that work. I think that was on purpose. So because we can actually see the area, I already knew the velocity at 3 was 2.5. So I think that was on purpose by the person who wrote the question. They're like, hey, if they think velocity, if they think about area, they'll already have the answer. Unfortunately, it does not give you the answer for x. You would still have to go through and find the formula. So x at 3 is 1/2 3 squared minus 1/2 3 plus 7/6. So it's 9/2 minus 3/2 plus 7/6. So it's 6/2, which is 3, 25/6. Sure hope that's right. So I did 3 plus this, which is 18/6 plus 7/6. Excuse me. Ooh, I'm losing my voice here. So I think I'm going to cut out here, but thank you all for joining me. And let's continue this tomorrow. So I'll be there a little before class answering questions, and I'll also be there in office hours after. All right. Good luck. Good luck with the studying. Thank you. Thank you. Here we go.